Okay, so the first thing we need to do for our stoichiometric equations is make sure that we convert everything into moles. So for this, we're given that we need to end up with 15 grams of iron. So I plugged this into the BCA table, which stands for before, change, and after. So if we're going to end with 15 grams, that goes in the after column. Then to convert this into moles, we just need to divide by the molar mass of iron, which is 56 grams per mole. And when we do that, we get 0.268 moles. So if we start with 0 moles of iron, and we need to gain 0.268, that means that this reaction needs to produce that much iron. So in order to find out how many moles of the iron oxide that we start with, we take this amount of moles and divide it by this coefficient, so 0.268 divided by 2. And then we multiply it by this coefficient, which is a 1. So that means that we started with 0.134 moles. Then we subtracted 0.134 moles and ended with 0. So then, to find out the maximum mass of the aluminum oxide that will be produced, we take this amount of moles that we started with, divide by this coefficient, which is 1, bring it over here, multiply by this coefficient, which is 1, and add that many moles. And then to convert that into mass, we just have to multiply by the molar mass, which would be 2 times the molar mass of aluminum, which is 27 grams, plus 3 times the molar mass of oxygen, which is 16 grams. So that's a total of 102 grams per mole, which gives us 13.7 grams. Okay, so the first thing we need to do for this stoichiometry problem is balance the equation. So to do that, we'd have a coefficient of 10, 3, 3, and 10. So next we're given that there are 52.9 grams of this, so we then just divide by the molar mass, which is 122 grams per mole. And that gives us 0.434 moles. So then plugging that into our BCA table, so at the beginning of the reaction we have 0.434 moles of this. We have excess phosphorus, and we're trying to solve for the mass of this compound right here. So as the reaction progresses, we lose all of this, and we end with 0. And we also lose, so then we would lose 0.434 divided by 10 and multiplied by 3 would be 0.130 moles for that, and then it would also be the same for this one, so we're going to start with 0 and then gain 0.130 moles. And for this one, we would also start with 0 and divided by 10 times 10 would be the same 0.434 moles. So now that we know that we ended with 0.130 moles of this compound, we just have to multiply this by the molar mass, which we see down here is 284 grams per mole, which gives us a final mass of 36.9 grams.